She makes the most pathetic noises.
Okay, we're about to go live.
Okay.
What? Okay. We should theoretically be live. Who can say? Who knows?
Someone at some point will let us know that we are live.
Somebody will collapse the wave function. Oh, there you go. People are saying they see and hear us.
Excellent.
We did it one last time for 2020. Can we drag this show across the finish line into 2021?
I hope so. This is probably one of the least challenging things we'll face this year.
It's true. We got the news that we should be fully vaccinated by September.
Like Canada?
Mm-hmm. So I don't know what your deadline is in the U.S. Sooner?
I don't think we'll know. No, it'll be later. We didn't order enough vaccines.
Yeah, I heard that. It's funny. So we kind of over-ordered.
Yeah.
So what happened was we messed up with the PPE stuff. And so Trudeau was like, I'm not going to make that mistake again. So I think he ordered 300 million doses.
Which is 150 million people.
For 30 million people. I think that's the number that I saw. It was some number like that. It was like some more than the people, and essentially, but the trick is that he spread his bet around. So he ordered on like many different providers, some of which may or may not deliver. So they just plunk down the money. So we've got the Pfizer one, the Moderna one, and then all the others. We have our order in.
So it looks like we ordered across all the different companies, maybe just a little bit too much, but we've only approved Pfizer and Moderna so far. Mm-hmm. Moderna doesn't have the distribution network.
Yeah.
There are no vaccine stations built in the US yet. And yeah, I need to open my audio recording software.
Yeah,
which is
so I think
depressing.
I'm not exactly sure how it's going to work. I mean, they're already starting to vaccinate now in Canada, but I mean, I will be pretty far down the, hopefully you'll get one fairly quickly, but it's going to be like, it's going to be medical personnel, and then it's going to be, people who are at that age risk. And then there's going to be people who have underlying health conditions or immunocompromised. Actually, probably frontline workers, I would guess. So it's going to be like, in fact, my daughter, because she works at a grocery store, will probably go next. Then maybe school children.
So what I was looking at here, and I may get this wrong, and it's currently being decided on a state-by-state basis in the United States.
Yeah.
Is what we're looking at where I am is healthcare workers and people who work in healthcare settings. So the janitors, the doctors, the phlebotomists, the nutritionists, all those people.
Yeah.
People who work and live in communal housing units. So this is senior citizens' homes. This is adult group homes for the mentally ill. This is prisons.
Right.
So any place where we're seeing huge amounts of die-off, which is a terrible phrase, due to the community living, are next. Then essential workers over 65, then essential workers who are younger. And I don't remember if it's in between is where they start getting to immunocompromised people over 65. And so I'm way down the list.
Yeah.
I'm looking at no earlier than July for a vaccine for me.
Probably, yeah. I also signed up for the Starlink beta.
Oh, excellent. I've heard that that's going on in Canada already.
Yeah, they've been doing some. They've been providing it to Aboriginal communities in far-flung Aboriginal communities in Canada that have had literally no internet. Like just
Yeah.
the word either like a tiny little connection to their entire city or no internet at all. And so we're at now like they're seeing 150 megabits down. Like it's crazy. So
Right.
yeah, yeah. So anyway, so I signed up. It's expensive, but I can justify it in that both
Yeah.
me and my wife use the internet, and
Yeah.
having a completely separate way to connect to the internet, since that's our whole job, makes a ton of sense. And I can do some reviews and such while we're doing it. So we'll see what happens.
Now, is it something that you can transport? So, like, say you go on vacation, can you take it with you?
Well, in the service agreement, they say that it's for one address, and so
Okay.
I don't know. Like, will it know that it's been moved and then give you a hard time about it? Like, what if you want to have it on your
Yeah.
boat, or what if you want to have it on your
Right.
RV, or what if you want to take it to your parents' place who have terrible internet and you want to be able to use the internet while you're staying at their place, for example? I'd be interested to know the answers to these kinds of questions. So I'm a journalist. That's the kind of stuff that I'm supposed to do.
Yes.
Yeah.
Yes. And you can figure these things out.
Yeah, exactly. So I will put their feet to the fire and find out for
That
everybody, not just me. All right. So for those of you wondering what it is that you have stumbled into, we are going to record a live episode of Astronomy Cast, the final episode before we go over the holiday break, and we won't be back till January the 8th. So
And so much cool stuff is going to happen during break. Have you looked at what all's happening just on Monday?
no, I mean we'll probably see SN9 fly.
That one we're still waiting to see because they canceled all the road closures that were planned for
Okay.
Monday.
Okay.
So that one, I don't think so on the SN9.
Okay.
It got pretty.
It
So the
fell over.
concern with it fell over,
Yeah.
and the concern is that while the wings did act as crumple zones, there may have been energy transferred to the inside, causing things that haven't been readily detected yet.
Mhm.
That I don't know about. But there's the solstice, so days are finally going to start getting longer
Of
again
course,
for
yeah,
us.
the Great Conjunction, yeah, on the
Yeah.
21st.
Then the Great Conjunction, and then there's also a tiny meteor shower.
Right on. Yeah, so we're going to try to bring you the conjunction live. We're rounding up astronomers around the world. Originally, our plan was to go at maximum conjunction, which is
Yeah.
around on the 21st at around 6 p.m. British time, like in Europe,
Yeah.
which would mean it's going to be more like noon or 1 for people in, like, say, the East Coast of the U.S.
Right.
But it's going to be tough to find a bunch of people in Europe, and the weather can be really bad. Even Corey Schmitz, who's in summer in South Africa, is saying, "Oh, yeah, I don't like my weather." So who
Oh,
knows what we're going to do? But I think we know a lot of astronomers. I'm sure we'll be able to find somebody who will be able to provide a
yeah.
live view. So we will try to bring it to you.
And I will happily crash that screen if the opportunity
Yeah, I'm
arises.
sure. I mean, like, yeah, I'm trying to think about this. Like, do we just like leave the screen up of just the two planets just there for hours and hours and hours, or do we like?
I'd be down with that and then just babble over the
Well,
top of
that's the
it.
question. Do we just hang out? Then people can just turn off the audio if they want, or we can just answer questions about space and astronomy, just hang out, and then
Exactly.
people can just decide what they want to do. If they don't want to
Yeah.
hear our nattering, then they can just turn off the audio and just enjoy the grand conjunction. So
What is today's episode number?
589.
589. Okay. We're going to hit 600 this season, I think.
Yes.
All right.
Okay. I'm glad we agree. I'm glad math will hold on into 2021.
Everything else is in doubt.
I know.
Everything else
Yeah.
is in doubt.
Yeah. We could hit infinity. Episode infinity. +1.
As long as we don't divide by cheese.
All right. Tell me when you're ready. Yeah. People are asking how I got onto the Starlink beta. I used my super secret insider knowledge. I went to the Starlink website and put in my name and got on their mailing list. So that's it. I didn't do anything special. I just signed up. And then
now you know.
When they rolled it out, they sent me an email. And the funny thing is they only gave me 7 days. So I had 7 days to pay up.
Yeah.
Or I guess offer rescinded.
This should start becoming available in the United States.
It is.
SpaceX is. Okay. Well, so SpaceX just bought the coverage rights to a whole bunch of property in the U.S.
Well, I mean, they were awarded grants to service underdeveloped areas. Yeah. So it's not like they bought the rights. They were given money.
They competed for the rights.
Yeah,
sorry, the wrong word came out.
Yeah. Whoa. Hey, how does closed captioning work on live streams when it's going out live? Lol, the captions have what Fraser is going to say before he says it. Well, so I think the way it works is there's a stream delay.
Yeah.
From Google for when we say things. Like, okay, so check out your watch right now. My watch says it is 12:14, 32, 33, 34, 35, 36, 37, 38, 39. So you can check and see how far behind you are on the screen delay from when we're streaming it. Okay, we should do our job.
Yes.
Okay.
Yes. All right. I'm ready to press record.
I am also ready to press record.
I am pressing
I pressed record.
And it's recording.
What? I find that hard to believe, but fine. Okay, here we go. Astronomy Cast, episode 589, Lunar Water Update. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. We are almost done with this year that shall not be named.
Yeah. 2021 is going to be so much better.
I don't anyone agree to hold its beer. That's all I have to say. 2021
is going to be the same. It's going to be like the recovery from 2020. We got some fixing to do. It's going to be, it's going to be a lot of work to get everything reorganized. But I have hopes.
As long as all the slopes are in the correct direction, because right now all the slopes are in the wrong direction.
Yeah, I think they'll go in the wrong direction for a while in 2021 too. But we're going to go out with a bang, which is going to be the Great Conjunction. Saturn, Jupiter, just within a couple of arc minutes of each other, right?
Arc minutes. Six arc minutes.
Yeah. And that's going to be on the 21st. And so hopefully you're going to be getting this on the 21st, on the morning of the 21st. And so we just want to give you one last reminder that this is your chance to see Jupiter and Saturn in the same telescope eyepiece.
And this is something that folks are already pulling off. They're already close enough, and they will remain close enough for a little bit afterwards. And what's amazing is this won't happen again in our lifetime. And in fact, the last time these worlds lined up this close together on the sky, no one got to see it. It was 400 years ago. And the objects were, positioned such that you had to know where to look during the day. And 400 years ago, people weren't looking during the day for Jupiter and Saturn.
Right.
So instead, we have only now. It's winter in the north, but hopefully we'll get some clear skies. I, for one, am going to try and pull out telescopes this weekend.
Yeah, and we're going to try to do a live stream of it so that if you've got bad weather or no telescope, then you can see it. But as everybody, I hope, has learned at this point, our ability to pull this kind of thing off is tough.
Yeah.
Live astronomy is the worst, but we will do what we can. All right. We've talked about the moon and its water many times here on Astronomy Cast, but there have been a bunch of big updates thanks to new research from NASA and others. Today, we're going to give you an update on the state of water on the moon and the plans to take advantage of it. Water on the moon. All right, Pamela, is there water on the moon?
Yes.
Okay. Have you got some patrons for us this week? No. All right. I guess we should go to sleep. So up until the fairly interesting research that came out earlier this year, what did we think was the state of water on the moon?
So we believed from the 2009 LCROSS data, from when we essentially threw part of a rocket at the moon and then measured the contents of what it tossed up into the air on impact. We believed from that experiment that there was either hydroxyl groups or water ice, and we thought it was water ice mixed in to the regolith on the moon.
So what's a hydroxyl?
So a hydroxyl is an OH group. It is something that is almost a water, but you can't drink it.
Don't drink it. Right.
So we thought there was either these OH groups, which are energetically very similar to water, but not exactly drinkable, or that there was water ice mixed up in the soil.
Right.
And this is one of those frustrating things of we impacted the moon to stir this stuff up. So where, how deep, how far down do you have to go? How hard is it to get out of the minerals? All these things were the questions that came out of that 2009 experiment.
And I think we had known that there was significant amounts of water ice at the poles of the moon. The Chandrayaan mission had helped map out the location of the water in the moon's permanently shadowed craters, and it's thought there's even deposits. But what LCROSS helped to show was that there's actually water significantly away from the poles of the moon in areas that are lit by sunlight constantly, and this water should have been evaporated off into space.
And this did it in a way that was more certain about what was being looked at. There's lots of ways to try and detect if water is there. One of the easiest ways, and this is something that we've done on Mars, on the moon, don't need to do it on Earth. We know we have water. The technique is to look for neutron spectroscopy. And these can get scattered when a cosmic ray, a high energy particle, impacts with water. Now, unfortunately, it can also maybe happen with other reactions. So when we are detecting these neutrons, it's not for certain that it's water. It's for probably it's water. And that's less satisfying. And that was the point we were at in 2009 was there's probably water. Right. Theoretically, there should be water in these permanently shadowed regions.
Yeah, but take a water bottle and hope is not a good way to explore. Right?
No, it's really not.
You want that certainty. Okay, so then 2020, we got an update to this story.
We did. And this was data that came to us from Sofia. Now, between 2009 and 2020, lots of different people had been looking in different ways, including spacecraft on their way to other worlds, to see if they could see the spectral signature of sunlight being reflected off the moon in a way that said, hey, there's water that is interacting with these photons. Look here, there's water. And unfortunately, again, we're back to that confusion of is it water or is it hydroxyl groups, which we had earlier. And so while we had intermediate measurements that were probably water, they weren't necessarily water.
Right.
Until a graduate student working with the Sofia team said, hey, while we're transferring the aircraft from one point to another and don't have science planned, can we look at the moon? Can we look in the infrared at this one particular molecular line that is indicative of water and only of water?
Okay, I need you to do two things now. One, you need to
Okay.
explain what Sophia is.
So Sofia is an airborne observatory. It's a 747 with a hole cut in the side and a telescope that can stick its shutter in that hole and capture light. And this 747 flies high enough up in the atmosphere to get above a lot of the water and other things that prevent us from being able to do a lot of infrared observations here on the surface of the Earth.
And
So,
that's leading into my second question, which is why
yeah.
was Sophia the right tool for this job? Why could only Sophia have been able to detect this water? You would think that there would be all kinds of telescopes on Earth that would be able to find this. Why Sophia?
Well, unfortunately, our atmosphere has a lot of water in it. And that water is at the same wavelength that water on the moon is at. So we can't see it from here.
Right.
And it requires a cooled telescope. Spitzer ran out of coolant a long time ago, and during its cold phase, never looked for this particular line. And there just hasn't really been anything else capable of making these observations.
And so you've got this, and if you haven't already, you really should take a look at a picture of Sophia, because it is a mind-bending piece of engineering. It is I forget how big the telescope is, like big, several meters, 3 meters, 4 meters. Anyway, it's a very
I don't think it's that big.
Yeah, it's a big telescope housed in the sort of rear of a 747, and it's got like a beautiful mount that keeps it perfectly stable as the aircraft is flying really high, like above as much of the turbulence as possible. And for hour after hour after hour, they're making these telescopic observations at this wavelength that no mountaintop observatory can view. Only a space-based observatory could do this. And so you've got this best of both worlds, where you've got the ability to come back down, modify your instrument, attach different science experiments, download your data, whatever you need to do, but at the same time, you're able to get above most of the atmosphere. It's essentially the most pristine view you could have. It is halfway to a space telescope, and it is it's a wonder of engineering. It is one of my favorite instruments.
And this is a 2.7 meter mirror, 9 feet essentially across just for the mirror. And so this is a massive system.
Yeah, so that's like a little bigger than Hubble.
Yeah.
Yeah.
And it flies on a 747. And so it has one of the coolest instrument stability systems that has been built by humans. And it's capable of doing things that currently nothing else can do.
Okay, so they during this flyover, this redeployment, they took some imaging of the moon, and what did they find?
They saw that absorption line in the spectra, in the scattered light from the sun that was reflecting off of the moon, that indicated there was water absorbing the sunlight. And it told us that in the mid latitudes, not at the equator, they looked a couple different places. They did not find water at the equator, but at the mid latitudes, there is water in the regolith and the minerals that is absorbing that particular color of light that only water absorbs out of the scattered sunlight.
And so they were able to confirm, and so essentially distinguish between water and that poison fake
Hydroxyl.
water. Yeah.
Yeah.
And so then were they able to get a sense of how much water there is?
So it doesn't look like a lot. It's kind of like a soda bottle's worth every few square meters of dirt.
Right. I heard that compared to, like, a fraction, even the Sahara Desert, the driest parts of the Sahara Desert has more water mixed in than the moon. But it's not zero.
It's not zero. Now, what we don't know is how mixed in to the minerals it is. So is this, as has been theorized to be able to form, rocks of ice that are covered in dust and thus partially protected? Is it individual molecules of water that are trapped inside the grains that would be super hard to extract? And it's in trying to find out how hard it is to get this water out that it starts to become a, well, can we rely on using this water? Or is this just neat chemistry that we know happens to be true?
Right. So then I think, when you had queued up the topic for this week's episode, you had said water and other volatiles. So yeah. I think, we sort of follow the conversation back. If we went back to the beginning of Astronomy Cast, I can't be certain, but I would assume that the conversation was something like the inner solar system is bone dry. The outer solar system has lots of water. Water and other volatiles are going to be really precious. But now we know that, in fact, there's a surprising amount of water. We're seeing this with the L-Cross impact. We're seeing this with the sample returns that have come back from Hayabusa, and we're going to assume from OSIRIS-REx as well, that it really looks like these asteroids have a surprising amount of water and other volatiles inside of them that could be used, well, like, one, to help you learn about the early solar system, but also to use these as resources to be able to support exploration and so on. So at this point, what do we think? How much of these other volatiles are there?
Well, we're pretty sure that there is the helium-3 that we're looking for. We're pretty sure that there's probably some ammonia in there. And basically, if something existed on a comet, it's probably somewhere in the moon. And this is where we get into the really interesting physics of what are called cold traps, which feel particularly timely with the movie Dune coming out, which I may be a little overexcited to get to see. So any of you who've read the book or seen earlier versions of trying to make this into a movie or a miniseries know that the desert world Arrakis has these catch traps that the wind blows in against the rocks, gets cycled down someplace cooler, and any moisture trapped in the air condenses out and forms essentially ponds, puddles, depending on size, within these cold traps. Well, that's what happens when you have an atmosphere and warmth. Moon has no atmosphere. It has warmth in sunlight, but not in shadow. And so what can happen on the moon, and we're now realizing this can happen at all scale sizes, is you can have something deposit water on the moon. So incoming crater, incoming comet, incoming asteroid. And the volatiles that are deposited on the moon, the carbon dioxide ice, the carbon monoxide ice, the water ice, it can get excited, it can get sublimated, it can float around as individual particles in the atmosphere of the moon and then settle down. Now, if where it settles down happens to be a cold trap, it just stays there. It's not leaving, and it can build up over time. And if it settles someplace that isn't a cold trap, it's going to keep moving Brownian motion until eventually it ends up in a cold trap. And so essentially what happens is all of these materials that sublimate away in sunlight will end up migrating to someplace cold where they can settle down to stay.
Right. And when you say cold, is that the poles of the moon, like those permanently shadowed craters, or are there other regions where we could find this as well?
Well, you can end up with permanently shadowed regions in all sorts of different places. So while we primarily think of the massive permanently shadowed regions, particularly in the South Pole Aitken Basin, where the geometry of the sunlight coming in at the equator and glancing over the top of the moon means that anything below the horizon is going to be in shadow forever. That's easy to understand, but we've all gone outside and dug a little hole that the sun never shines directly into.
This sounds like our last week's episode.
So you can have these little holes of all sorts of different sizes, and they could represent places where water can stay. And it's now estimated that order of 15,000 square kilometers of the moon may be capable of trapping water.
Wow, wow. And so there could be these deposits, these cold traps across the moon that you could be finding. And so all of these impacts that are happening on the moon are releasing these volatiles. They're finding some other spot. They're condensing again, and they're just waiting for people to go and find them. That's super amazing. So then what would it take for us to be able to get our hands on them? Because I mean, we've talked about this in the past, that water and other volatiles are really are a critical piece to being able to continue your space exploration, to essentially refuel at the moon. You need water. Split it up, hydrogen, oxygen, you've got rocket fuel. What would it take to get our hands on this stuff?
Well, and this is where it gets to the we don't know. What else is bouncing around in the atmosphere? What else is in the cold traps? How does the moisture get layered? Are there any chunks of comet left hanging out in the bottom of a crater somewhere? We don't know the answers to these questions. And there are models that basically say that some of these smaller cold traps may literally have essentially a rock of ice. But that's not all the models. That's not a consensus view. We don't have enough data to know what is most likely. And so while this may be possible, it could be that we're going to essentially have to do like we do when we're processing ore here on Earth. You dig up a whole bunch of soil, in this case, bake it, which is a highly energetic process, grind it up. And between the grinding and baking it, let me say that sentence again. Between the grinding it up and the baking it, you can release the volatiles. Again,
Right.
highly energetic process, not cheap. Cheaper maybe than carrying all of our water with us.
Right. I guess that's the point. If you're looking at $1 million a kilogram or whatever it's going to cost to carry stuff all the way from the Earth to the moon, then setting up some kind of machine that bakes. It was interesting. I did an interview with a scientist who's developing a method to develop solar panels on the moon. And he was saying, the first thing you really need on the moon is energy. And the second thing you need on the moon is energy. And the third thing that you need on the moon is energy. And you can absolutely see that with being able to bake regolith, to get at the volatiles, to these various ideas to turn regolith into bricks, to high heat extract aluminum and titanium and all of these minerals that you might want off the surface of the moon. Again, it's like, I'm going to rabbit hole for 1 second here. People talk about this idea of like mining the moon and how difficult it's going to be or how the incredible potential it's going to be for mining the moon. The moon is the worst.
Yes.
It's just terrible. It's just a tangled, shredded, just wasteland of
and it has
glassy...
more gravity than we want. It has too much gravity.
Yeah. And so it's just like, I don't know, it would be like trying to drink in the middle of the ocean. It would be like trying to grow in the middle of the desert. It's terrible. It's just, and so no, we don't want any of what the moon has to come back to Earth. But if all you've got is the moon, it beats the alternative of trying to bring that stuff from Earth.
And this is where ideas that have been going back for decades and decades, and that we currently see in TV shows like The Expanse, which is also back with the new season, which I am excited about.
Except only 3 episodes. That is unkind. Let's just say that things descended into chaos around the old Cain household after we only got 3 episodes. One night,
Well,
things were fine. We ran out of episodes. Those were dark times.
yeah. So I'm gonna probably binge watch tomorrow using the Twitch watch feature, but that's a different story.
Right.
The story that I wanted to reference was one of the things that we see in The Expanse is this idea that there's a whole lot of icy objects out there that aren't very big. And we may in the future be able to go out and take these lower mass objects, mount engines on them, and move them where we need them. And it may be easier to build a fuel depot just beyond Earth and use that instead and not deal with the moon's gravity at all.
Wouldn't it be cool if there was like a comet that had been brought into the inner solar system that was like, say, on an orbit, like that was on like a co-orbital position with the Earth, and so it would always be there at like at the Lagrange point, and it would be like this permanent bright comet that's always in the sky, and you would look at that and you would say that is our fuel depot, and yet it would also just have this enormous cometary tail trailing off behind it because it would be in the inner solar system, and it would be like a super bright, it would only be a couple of not even, it would be just a few hundred million kilometers from the Earth. It would be amazing.
So I'm going to say something I don't think I've ever said to you before. You're thinking too small.
Oh, okay. What? Wait, what?
So,
How's that even
so
possible?
one of the awesome things about orbital dynamics is if you put something in a slightly bigger orbit than the Earth, it's going to orbit more slowly. This is why we lost track of, well, we didn't lose track of, this is why we lost ready communications with Spitzer as it trailed behind us. Now imagine that you grab like 5 or 10 objects, distribute them equally in a slightly larger orbit so that we're always leaving one behind
Right.
and moving towards the next.
You would have to
Thus-
keep them stable. That would be tricky, though.
Once they're in orbit, they're in orbit.
Yes, but they would crash into each other. They would interact with each other. Like they'd be in
Orbits,
Are you talking about our orbit, or are you talking about their orbit? Like around the sun
Their
or around the
orbit.
Earth?
they go in orbit around the sun
Yeah, yeah.
on a slightly bigger orbit than we do,
Right. Yeah.
on a similar ellipticity orbit with the same nodes.
Right. Okay. Okay. I got it.
And so they should stay reasonably evenly spaced.
Right.
And because they're comets, they're going to outgas, or because they're
Yeah.
icy bodies, they're going to outgas. And that is what you have to counteract.
Right.
But
So there will always be a bright comet in the sky with an enormous tail, and that is a symbol of humanity's gateway to the exploration of the rest of the solar system.
I think you'd probably want to eventually coat them over to stop the outgassing, but the building of this system would be amazing.
Yeah. Yeah. I love it. That's so cool. So until then, we're gonna have to go take ovens to the moon, bake the
Yes.
regolith, get at the volatiles and water, and hope to jumpstart that future where we bring in the the comets to support the future exploration. I like this this bold plan, Pamela. This is it really. You're right. I had never even conceived of such an idea to have multiple ones. So there's one that's always close. I love it.
Yeah. Basically, communication satellites that have water and allow us to communicate around the entire solar system. We're going to need this anyways.
Yeah,
Just make it out of stuff we can mine.
that's so cool. Fantastic. Well, do you have some names for us this week? For real this time.
I do. This is going to take me just a moment. So sorry, everyone. I got sidetracked by the awesomeness of this episode. So, as always, we are supported through the generous contributions of people like you. And this year, we had seen a decrease in those who were able to support us that we know represents that a lot of you just aren't doing okay. And we are so grateful to all of you who are doing financially okay and have taken the time to support us and allow us to just keep paying our humans to help us put together what you see before you. So this week, I would like to thank Catherine McCabe, Janet Wink, Aurora Lipper, Emily Patterson, Just Joe, Ed Loves Science, Elga Bjorkerg, Gordon Dewis, Sinai, Joshua Pearson, Bill Hamilton, Frank Trippin, Richard Riviera, Alexis, Jack Mudge, Thomas Sepstrup, William Andrews, Jeff Collins, Harold I'm going to say this one over. Harold Bardenhagen, Ben Floss, Merrick Verdarni, Arctic Fox, Ron Thorson, Nate Detweiler, Philip Walker, Martin Dawson, Brian Grigory, and Elad Avron. Thank you all so much for being here and supporting us week after week through the years.
And for those of you who are just getting the podcast now, just a reminder, this is the last episode we're going to be doing for 2020. The next one comes out January the 8th. So you have 3 weeks to catch up on all those other podcasts that have been filling up your podcast player before the next episode. You're welcome. I hope you all have a great holiday. Pamela as well. I will look forward to talking to you again in the new year.
See you after the year that shall not be aimed.
Right. Then they save.
And now we save.
$5.89.
I just saved it in the wrong directory. Let's try that again. Okay, now it's in the right directory.
Okay. And then I'm going to upload right now.
Okay.
Just so Richard doesn't have to send me that email, which he has to send me every week.
This is why we need people like Richard.
Yeah.
The two of us are not to be trusted. There are people in our lives that keep us on the straight and almost narrow as we try to rabbit hole and escape in all directions.
Remember when we used to do all this stuff ourselves? It was a disaster.
And we were so much younger and needed so much less sleep.
And we're like, I just remember we would be negotiating every week. Like, when can we record? I can record now. You can record then. Oh, I've got children, babies. It was rough. And it's so funny, you know, and like, even if, and then when we shifted over to doing these things live, and we would be 15 minutes late, 20 minutes late, who knows? I feel like now we're just like Swiss trains most of the time. I think it's hilarious that every piece of the puzzle comes together. You know, we start when we say we're going to start, and we release our episodes, and that is because we don't do it.
No, we have humans.
Yeah. That is the one thing for all of our capabilities. That is not one of them. Is sort of handling all of this minutia and being able to stay on target. So thank you to everybody who is like behind the scenes, and that's of course, and thanks to everybody who's a patron supporting us.
Yes.
All right, we've got questions. A. Middles asks, I wonder how far down you would need to dig on the moon before the sun's radiance no longer penetrates. I get the impression that the surface with its albedo would prevent a lot of that heat from being trapped. So how far down do you think you could go before
It's not very far. It's centimeters.
Yeah, so it's a few centimeters down, and you've got whatever's there is going to stay there. And this is, I think, the incredible discovery that you're seeing this. I mean, we're waiting for the samples to be studied from Ryugu from Hayabusa, but that's what they did. They blasted it with a tank shell, grabbed some samples from a little deep down, and we'll know what the interior of an asteroid is compared to the exterior.
We have the coolest correction from last week. So last week we talked about how we'd seen the Ryugu sample, and it was super black and it was really awesome. Well, it turns out that the photos that we were looking at were not of the sample itself, but of stuff that got stuck on the entrance of the sample container.
Yeah.
And is inside the chamber around the sample container.
Yeah.
So the stuff that got stuck is in and of itself a really cool, nice sample.
They ended up with 5.4 grams of material from Ryugu, and the goal was 0.1 grams. So they got over 50 times as much material as they were hoping to get.
And I want to say that a gram is about the weight of either a penny or a dime.
A gram?
Yeah.
Less than that. Like
Okay.
5 grams is about a penny.
Okay, so dimes are much lighter weight.
Or well, it depends on the country you come from.
This is true.
Yeah.
Sorry.
Our dimes are lighter than our pennies, but we don't have pennies, so I don't even know what that means anymore.
All right.
Yeah.
So we're a bit crazier here. Anyways, it's not a lot, but it's awesome because it comes from another world. And the chamber was a vacuum when they collected all of the stuff. And during the passage from Ryugu back to Earth, the sample outgassed. Volatiles inside the sample escaped into the chamber, and they have been captured and can be analyzed.
People are saying like a gram is about a paperclip. So if you just had like 5 paperclips, that's the amount.
Okay.
Gordon is saying 1 milliliter of water is 1 gram. Yeah, thanks, Gordon. We all know how much 1 milliliter of water is. Okay. Hal McKinney asked, how close to the moon's surface could we orbit a satellite?
I don't know. I know we've been as low as 15 kilometers. I don't know how much lower we can get than that. There is just enough drag from stuff suspended above the surface of the moon that it disrupts, and there's enough gravitational variations from the topographic differences.
Yeah, that's the big problem, is the gravitational perturbations eats spacecraft. Many spacecraft have gone into the moon because they just, you've got it's not just the moon too, you have the interactions between the moon and the Earth.
Right.
And so you got the Earth modifying the orbit of the satellite as it's going around the moon, going up and down over the mountains, and it ends up in spacecraft smashing into the moon. So it's not about how low you could go, it's about how low you can go and handle the bully gravity from Earth. But like the Lunar Reconnaissance Orbiter has been there for a long time and doing great.
Yeah. It and the Mars Reconnaissance Orbiter, its sibling, are two of the hardiest science-taking spacecraft we've got. They are both amazing testaments to what we can build.
Yeah. Corey S. asks, is it possible to combine hydroxyl in some process to get water, like HO plus HO equals H2O plus
I'm
O?
sure you can. I just don't know what the OH is bonded to. Mm-hmm. And that gets to the issue of an OH isn't going to generally hang out by itself. So it's going to have bonded to something else.
Unc Willie is asking, would the solar wind blow away the loose molecules? So we talked about those molecules going into cold traps. Would the solar wind just blow them all away?
So some of them, yes. Some of them will get the chance to descend back down to the surface into the cold traps.
Harjon is asking, could you make a lens out of ice on the surface of the moon?
Yes, but I assume that just like ice here on Earth, that it's extremely difficult to get completely clear ice. You have to go through all sorts of bells and whistles and freeze things slowly in order to get completely transparent ice.
Yeah, and stir it. I forget what you have to do. But I like the idea of the rotating metal telescope. So you make like an Arecibo, and you put some kind of, you form a nice, you form the shape of the telescope, and then you have a blob of some kind of metal that sits at the bottom, and then you start to turn the telescope, and then
Yeah.
the centripetal forces carries the material up the
Well,
parabola in sort
as
of the
I'm
perfect
sure you
way.
know, there was one like that built in Canada with liquid
Yeah,
mercury that was just slightly toxic, but
yeah,
did good science when it wasn't being too
right.
entirely toxic.
But it can only look up.
Yes.
It can only look directly overhead. You can make a spherical mirror, and so that's what you do. You'd make a spherical mirror, which
Yeah.
allows you like
You move the
Arecibo.
secondary.
Yeah, like Arecibo. The key with Arecibo is that you can move the instrument package around and then use it to change what it's pointing at, and so you can
And the
do that.
Hobby Eberly telescope and the South African Large Telescope both also use the same concept.
Yeah,
They're each inclined off axis to maximize the parts of the sky to do the science they want, but these are spherical mirrors that move the secondary around.
yeah, and the Daniel K. Inouye is also, I think, the solar telescope in
Yeah,
Hawaii.
it is.
Yeah, and it's got an off-axis second mirror. Um, Horizon Braves asking, is there a way that they could use Sofia idea for radio astronomy? Thinking of like a replacement for Arecibo.
Um, it it's not useful.
Yeah, it's not necessary. That's a
Right.
wavelength that,
Radio waves, most of the ones we're interested in make it to the surface of the planet already. Um, and with radio waves, because they're so much bigger than infrared waves, you need significantly larger detectors. So that 2 point something meter mirror would not cut it for doing a lot of radio work.
yeah.
This is where the kilometer order of magnitude of Arecibo was so important.
Hal McKinney asked, where in space does water form initially? Where does the hydrogen first meet the oxygen?
Wherever it feels like.
Like
It's
if hydrogen meets oxygen, you get water.
or a hydroxyl. It depends on the
Right.
combinations, but yeah.
Unc Willie's asking, are there any major bodies in the solar system where we haven't found evidence of water? I mean, I'm thinking there are permanently shadowed craters on Mercury even.
Yeah. And there is water in the atmosphere of Venus. I
Yeah.
mean, I'm sure there's moons that we haven't detected water at, but that's a lack of detection due to a lack of being able to look hard enough.
Yeah. Hal McKinney is asking, might there be a slight amount of gravitational lensing during the conjunction of Jupiter and Saturn?
Not that we'd notice.
No. We talked about this idea of having a solar telescope that if you move out to 550 astronomical units, you can use the light from you can use the gravity from the sun to act as a lens to see incredible resolution out into space. And people always ask me, like, oh, could we use Jupiter? Well, the problem is Jupiter has less gravity. So you could, but you would have to then go dramatically farther away to be able to get the same effect. So instead, you'd be having to go, I forget, I looked it up one time. It was like 10,000 AU, not 550 AU, to have a worse telescope because it's not
And
as powerful as the sun.
And there have been some cool experiments done that I wouldn't so much call gravitational lensing as gravitational deformation of light path, where they tried really hard to look at how Jupiter's gravity would bend the light from background quasars. And it's such a hard observation that so far we haven't gotten anything that definitively allows us to do the kinds of science folks would like to do.
Yeah. Mr. Box Monkey asks, if Earth affects spacecraft orbiting the moon so much, then does that mean orbiting one of Jupiter's moons is even that much harder?
It depends on the topography. Um, so the moon has massive craters, massive mountains. Um, I don't know if there's any significantly smoother, similar mass worlds out there. Like I just don't know
Mm-hmm.
what the extremes in topography for Ganymede are, for instance. So if for whatever reason Ganymede's average difference between crater floor and mountain peak was much, much less than the same difference on the moon, then sure, it would be easier to orbit.
Yeah.
I just don't know though.
Very cool. Okay, so we're kind of we're closing in on the end of our time. What are you going to do over the holidays? What's your plan?
Oh man, so we're not totally into Christmas around here, and we normally use the holidays to travel all over the place, but clearly not
Yeah.
this year. So I'm thinking I'm going to redo the living room, and bake. I'm going to make a freezer's worth of tamales and bestow tamales on Annie Wilson, who's one of my co-hosts over on the Daily Space, who happens to live here in town. We're currently quarantined from each other, but we do what's called patio mail.
That's
So
cool.
we take turns leaving things on the front patio to swap.
We yeah, we're not big on Christmas either around these parts. We've got all of our Christmas gifts under the Monstera, as opposed to a Christmas tree.
These are the only Christmas decorations in our house, and it's because I'm reading The Hogfather on Twitch.
Right. Yeah. Yeah. And yeah, I had to warn Chloe because she's coming back for Christmas. I'm like, yeah, just to let you know, no, it's not a big festive place around here anymore. So, but we do, and Carla, my wife, is vegan, so we don't do like turkey and things like that. But we do, like, we call it Cakesmas, and so we make a bunch of cakes.
Oh,
Yeah.
that's
and
excellent.
then eat them and feel sick, but also put a bunch in the freezer and things like that. So usually it's a way to just, because like there's times when you want to experiment with interesting dishes, but you just don't have time. Like, sometimes you just need to
Yeah,
feed family, but when you've got a little
right.
time on your hands, you want to just explore. I'm like, can I make macaroons? Can I make I forget, there's some kind of, and so I will try to make like vegan versions of tasty treats that Carla likes. So that's sort of what I do.
That is awesome. Our stove is not up to that challenge. Our stove is from the 1950s. It
Right.
is within plus or minus 50 degrees of target at any given moment.
Yeah.
It's not that trustworthy.
Yeah. Cool. Well, so we've reached the end of our hour. I'm going to do another open space on Monday, and then I think then I'll stop doing them until the new year. But thank you everybody for joining us all the way through 2020, the year that was. Thank you to all of the moderators. Thanks to, of course, Nancy Graziano for helping to herd all the cats. Thanks to Beth and the rest of the team keeping an eye on what's happening over on Twitch as well. And we really appreciate everybody's help. Pamela, it's been a pleasure again for another year, and we will see all of you in 2021. Thanks, everybody.
Bye bye.